Sanding is a necessary evil on most projects. You have to do it, and most people hate it. But what do you do if you've got an inexpensive sander that's got a dust bag like this, which isn't particularly great, and you want to hook it up to your more expensive dust extractor like I've got here on Bosch? Well, that's fairly simple. Using FreeCAD and a 3D printer, you can design an adapter that connects your inexpensive sander to your dust collector, like this. This adapter replaces the standard connector. Plug it in. That took longer than I thought. Now I don't need the dust bag anymore. I'll show you how I did it. Stick around. I'm going to start with the Bosch end of the adapter. I want this design to be reusable, so I'm going to store that in a separate file. This will mean that I simply have to design the part that fits on the other tool and then join it with the Bosch one and print it, and then I've got my adapter working. I'm going to create the tube in the part design workbench by creating a sketch on the XY plane. And then I'm going to create two circles. One representing the outer diameter of the dust collector hose and the other representing the outer diameter of the adapter itself. I'm going to use a construction line to constrain the wall thickness between the two circles, and that's going to be perpendicular to the inner one. So I use perpendicular constraint to do that. And then we'll convert the line to be a construction line, which I forgot to do. Lastly, I'm going to set the length of the construction line to the wall thickness. Now, because I've got a 3D printer, I have a spreadsheet which defines tolerances, which I've set to be the diameter of the print nozzle. And when I'm using it, I'm going to double the tolerance just so that I get a snug fit. The radius of the inner circle becomes the outer diameter of the Bosch hose plus 2 times the print tolerance. The reason I've done it this way is no matter what the tolerance or the radius of the inner circle becomes, the wall is always going to be 4 millimeters thick. I don't have to make a complex equation just to have the wall thickness. So we'll save the sketch, and then I'm going to pad it out using the pad tool, and that's going to create me my tube. And again, I'll just have that stored in the spreadsheet. So that's the easy part done. Now we're going to look at putting in the holes for the locking nubs. We're going to create a new sketch, and it's going to be on the YZ plane because I want the holes to be in the side. Just view the section of the sketch. I'm going to create the hole using a rounded rectangle. Then going to be symmetric to the vertical plane. Going to have a radius of 3 millimeters, and we'll make it symmetric to the center line using a symmetry constraint. And the width of the whole thing is 12 millimeters. And the length of the whole thing is 15 millimeters, or the height. So I've got it in here. Now, the other thing that I've done is I've set it 9 millimeters down from the top. So I need to bring in the geometry from the tube itself so that I can reference that, and then I can set that height. Now, you'll notice occasionally I forget to move the equation editor dialog box. And because I've got two screens, it's just rolling over to the other screen rather than truncating it or doing anything else. So nothing to worry about there. It's just normal behavior with the windows, but I'll just forget to move it. Now that I've got the hole designed, I need to create a pocket in the side of the tube. I'll close the sketch. You can see that the sketch is actually in the middle of the tube itself. And we don't want that because I want it to actually sit on the side of the tube itself. So what we're going to do is we're going to change its location through the properties. We're going to come across and we're going to change the attachment position. And we're going to move it in the y-axis. If I rotate that, we should see that the sketch sort of touching there. Now I'm going to create a pocket for that. And we're going to do a type of 2 dimensions. And I'm just going to go 5 millimeters in each direction. So the next thing I need to do is put a chamfer around it. And I'm just going to select all the edges and then create a chamfer. And we're going to set the distance from the spreadsheet again. And the last thing that it's got is that there is actually a guide that guides the knobs in. So we're going to create another sketch on the YZ plane, and we're just going to go to the section view. And this sketch is just a straight rectangle, again, symmetric to the vertical axis. So we'll use a symmetry constraint to do that. Not going to worry too much about where the end part is at the moment. We'll move it into position first, then we'll set that. Again, we're going to move it by the same amount as the original sketch. Again, it's just half the outer hose diameter. Come back into the sketch, and I want the bottom to be about 3 millimeters below here. So we'll bring the chamfer in. In fact, we want the outer one, but that was not too much of a big deal. And then we will drag it down. This guide's not going to work very well the way it currently is because it's just flat. What I actually want is a sloping guide. So again, we come back into the sketch and we're going to change its map mode. And what I want to do is just rotate it around the x-axis 5 degrees. That's put an angle on it. And to show you that, we're going to create a pocket. You see now it's on the angle. And I'm going to make the depth just 2 millimeters because it doesn't need to be that deep. It's about halfway. As you can see, it's not quite in the right place. We're just going to move it back manually until it gets to where I want it to be. Change the attachment offset. In fact, we'd use the map mode and we are going to move it back another couple of millimeters. Just take that off. The idea being is it just guides the nubs into place. Now, the last thing we've got to do to finish off this part of it is just to make a polar pattern of the pocket for the finger holes and everything else in between. So we just select them all. We come to polar pattern and we're just going to make 2 and we're going to rotate it around the Z-axis. And that completes the Bosch part of it. If you're finding this video useful, please like and subscribe, and this will help share the video with others. So now we'll move on to doing the Ozito end of the adapter. I'm going to create a sketch on the XY plane, and basically it's the same as starting off for the Bosch one. We're just going to create a tube, and we're going to use a construction line to set the thickness of the wall, just like the other one. And that construction line is going to be perpendicular to the inner circle. Again, 2 times the tolerance is added to the outer diameter of the flange on the Ozito sander to get the diameter that we need for the inside. Close that, and then we pad it out to make the tube, and it's going to be stored in my spreadsheet as usual. We've got to convert this one to a construction line. That looks better. Now, like the Bosch adapter, we need to punch some holes through the side to allow it to be locked in. I'm going to use slots to do that. And the first one I'm going to do is a vertical slot on the inside that allows the locking knobs on the Ozito sander to slide in. And then I'll add another one which allows us to rotate the whole adapter assembly to lock it in place. So I'm going to create another sketch. It's going to be on the YZ plane. And we're just going to jump into section view. So I'm going to create a slot which is symmetric around the vertical axis. The width of the slot is 3.5 millimeters. Set that now. And this top radius here, or center for the end of the slot, is going to be 5 millimeters in from the end, so the outside edge. As you can see, the sketch is centered, so we're going to have to move that half the diameter of the tube. So again, we do that in the attachment offset and change the Z offset. And that should put it pretty much right on the edge of the tube. Now what we're going to do is we're going to create a pocket, and this pocket's only going to go in a few millimeters because it doesn't go the whole way through. So we create a pocket. We're going to create a pocket that is about 2.5 millimeters deep. So the height of the knob on the Ozito sander is 2 millimeters, and I'm going to give it twice the tolerance of the printer just to make sure there's some room for it to move. Put it the wrong way. Got to reverse it. And now the next thing we need to do is create another sketch which will be pushed through the whole side so that when the locking nub slides in, we can then rotate it to lock it in place. So create another sketch. Again, it's going to be on the YZ plane. We'll go into section view, and this one is actually a horizontal slot. Again, its diameter is going to be 3 millimeters. And we want it to be 5 millimeters from the bottom, just like the other one. Then we will create a pocket on that one. Again, we're going to use it in both directions just to clear it all out. And we'll make it 6 millimeters in both just because it's not quite on the edge of the tube. That should clear it all the way through, I think. There we go. And like with the Bosch one, what we need to do is just polar pattern it. There's only two. Could have just punched them the whole way through, but I prefer to do the polar pattern because in other options there might be 3 or 4 nubs. And again, we just rotate it around the base Z-axis. And that's done. What I'm going to do now is start assembling this, but it's not quite ready and I'm just missing one part, but we'll show you how that works in a moment. So I'm going to create a new body and I'm actually going to call it complete adapter. And I'm going to use shape binders to bring the Ozito connector in. And I'm also going to bring the Bosch connector in using a shape binder. Turn off the original Bosch one and the original Ozito connector so we can just see the shape binders. And what I'm also going to do is transform the Bosch one up a bit. Immediately you can see that they don't match. The diameters are different and so on. So what we're going to need to do is develop a small joiner that goes in the middle. So what we'll do is we'll create another body and we'll just call it the joiner. And we will create 2 sketches on that. So to create the joiner, I'm going to first of all bring in the Bosch connector using a shape binder so that I can just simply grab the geometry from there. Now I'm going to create a sketch on the XY plane. And I'm going to bring in those 2 circles. And then I'm going to create 2 of my own. Now you could constrain these if you wish. I'm not going to in this point. And with the sketch, this joiner is going to be 20 millimeters long. So again, we'll move it just in the Z axis 20 millimeters. And then I'm going to bring in the Ozito connector using a shape binder and do the same thing. Create a sketch on the XY plane. Bring in the geometry of the shape binder. Create circles on it. Not really constrain it that much. And then hide the binder. And what that'll do is that'll give me 2 ends of the joiner. And now I'm just going to use a loft to create the shape. So I'm going to select all the bits. And use the additive loft. Click OK. And there is my joining part. So we come back now to the complete adapter. Make that the active body. Bring the joiner in with the shape binder. Hide that now. Turn the others on. We could just move that out the flange length. So find that placement. Position. Z-axis minus equals minus. And with the Bosch one, I know that the length here is 20 millimeters because we just did it. So let's just move that back to where it should be. And that was just 20 millimeters. So now we've got the 3 parts together. And all I'm going to do is I'm going to just join them or fuse them together to get the final part. And there it is. This adapter now lets me connect my Bosch dust extractor to my cheap or inexpensive Ozito sander. So now I can export the adapter into STL so it can be sent to a 3D printer for printing. To do that, you select the part and you come to the file menu and select export and select, so it's an STL mesh. Save that. And I got my son to print it because it's his 3D printer, and he took it into Cura Slicer and printed it on his Ender 3D. You can download the STL for this adapter free of charge via Buy Me a Coffee or Patreon. If you're a Buy Me a Coffee or Patreon member, you can download the complete models of this adapter as well. I hope you found this interesting. Please like and subscribe to the channel if you liked it. If you'd like to support me financially, you can do so via Patreon, Buy Me a Coffee, and PayPal me. All donations will be used to improve the channel. Thank you very much for watching. Have a wonderful day.